We hear so much about the massive, eye-watering cost of training AI. But what if I told you that's just the opening act? Today, we're diving into the hidden engine that does the real work of AI and why it's about to become the most expensive and most important part of the whole equation. Let's get into it.
Think about that scene for a second, that incredible, life-saving flash of insight that comes from the machine. That's not the training model just sitting there. No, that's the inference engine in action, turning a sea of raw data into a critical diagnosis in the blink of an eye. And this isn't just some technical detail for engineers to worry about. It's an economic earthquake. Just look at this. By 2025, the cost of just running these inference engines is on track to be 3 times higher than the cost of training them in the first place. So why is that? Well, it's simple. Training happens once, but inference, that happens with every single question you ask, every single time you use the AI. This is where the real work and the real cost of AI is headed. So let's go ahead and properly introduce this unsung hero. It's the part of the AI that takes all that abstract knowledge it learned during training and turns it into something concrete, something actionable. You could say it's the bridge from just knowing something to actually doing something. So what exactly is an inference engine? Honestly, the best way to think about it is as the AI's reasoning brain. It's the part of the system that actually does the thinking. At its very core, an inference engine is a logical processor. It takes all the information it has access to, whether that's a set of hard-coded rules or a bunch of learned patterns, and it uses that information to make decisions, to generate predictions, and to figure out new facts. In a classic AI system, the process looks a lot like how we think. The knowledge base, that's like our long-term memory, just packed with facts and rules. The inference engine is our conscious thought, the part that's actively processing everything. And the working memory, that's kind of like a mental scratch pad, a temporary space to hold ideas while we're working things out. It's a surprisingly human-like process, right? Okay, but here's the thing. Not all inference engines think alike. They pretty much fall into 2 broad categories, and each one really represents a different era of AI development. And this slide just lays out the difference perfectly. On one side, you have the rule-based engine. Let's call it the detective. It follows a very strict set of if-then rules. Its biggest strength? It's totally transparent. You can trace every single step of its logic. But the downside? It's brittle. If it runs into something that's not in its rulebook, it just breaks. On the other side, you've got the machine learning engine, our experienced doctor. It doesn't use a checklist. It relies on subtle patterns it's learned from thousands of past cases. Its strength is that it's incredibly adaptable, but its great weakness is the black box problem. It often can't tell you why it made a certain diagnosis. Now, focusing on our rule-based detectives for a second, they basically have 2 main strategies. Forward chaining is like starting with the clues, the facts, and seeing where they lead. For example, the butler has muddy boots, the mud matches the garden's soil, therefore the butler was in the garden. Simple enough. Backward chaining is the opposite. It's like starting with a suspect, a goal, and working backward to see if the facts support it. Okay, if the butler was in the garden, he would have muddy boots. Let's go check his boots. 2 totally different ways to solve the same crime. So whether it's a detective following a rigid set of rules or a doctor spotting complex patterns, these 2 kinds of thinking are at work all around us. The real question is where? And the answer might surprise you. It's almost everywhere. Let's take a quick look. In really high-stakes fields like healthcare, these engines are powering diagnostic tools and predicting disease risk from medical scans. And in autonomous vehicles, they're the brains that fuse strict safety rules with the pattern recognition of a neural network to make those split-second driving decisions. They're also the silent guardians of our digital and financial worlds. In cybersecurity, they combine known virus signatures, which are basically just rules, with machine learning that spots weird, unusual behavior. And in finance, they're making decisions every single millisecond in credit scoring, fraud detection, and high-speed trading. And of course, they are absolutely all over the consumer AI you use every single day. That engine recommending your next movie on Netflix, the chatbot answering your questions, and yes, the very core of every large language model generating text, it's all powered by inference. But the story definitely doesn't end here. The limitations of the engines we have now are forcing a really rapid evolution in how we build these AI brains. This is the absolute gut check question facing modern AI. When a model denies someone a loan or makes a critical medical recommendation, an answer like, I don't know, it just felt right, is not good enough. That's the black box problem, and it's a huge one. And that's just one of several massive hurdles. You've got the huge computational cost we already talked about, needing giant racks of GPUs just to run constantly. You have the challenge of data drift, which means making sure the models stay accurate as the real world changes around them. And of course, the ever-present ethical risk. Biased inference can and does lead to incredibly harmful decisions. Each one of these is a major barrier to creating AI we can truly trust.
So what's the solution? Well, it's looking more and more like it's the hybrid engine. This whole approach is about combining the best of both worlds. You get the clear, explainable logic of our detective, fused with the flexible, pattern-matching intuition of our doctor.
At the end of the day, the ultimate goal here is to move AI beyond just making predictions based on correlation. The future is about creating engines that can use causal inference to genuinely understand why things happen. We're talking about evolving them into true cognitive systems that can reason, reflect, and even plan. So while training might be what builds the AI's library of knowledge, it's the inference engine that actually sits down, reads the books, connects the dots, and writes the next chapter. It's the hidden, hard-working brain that truly brings artificial intelligence to life.